In this video, we are going to discuss injective and surjective functions. So these are two different ways we can look at functions. We're going to define what injective functions are, we're going to define what surjective functions are, and then we're going to show some examples. Now recall by the definition of a function, each input can only have one output. So if I try to define a function like this, and just as a reminder about what this notation is about, the top row, those are the inputs, the bottom row, those are the outputs, and if you want to know what the output is for a given input, you look for the input on top and you look for the output below. So for instance, if I want to find out what f of 2 is, 2 is in the top row, right below that is a 5, so f of 2 equals 5. However, this particular, well, I'm going to call it a function, but it's really not, has an issue, right? And its issue is if you look at the first column and the third column, it gives two conflicting values for f of 1, right? So the first one says f of 1 is 2, the next one says f of 1 is 3, and since you have two outputs for one input, that means it's not a function. Now, it is possible to have two inputs that give the same output, right? That's not contradicting any kind of function definition. So if we have something like this where the inputs are 1, 2, 3, and 4, look at the first and third columns. There you have f of 1 is equal to 2 and f of 3 is equal to 2. That's okay. F is still a function. Each input has only one output, even though you have an output that it's associated with two inputs. It's still a function. Now, what we want to do, looking at that second example, is we'd like to distinguish between functions whose outputs are all different and functions where some of the outputs are the same. So you notice in that second example that we did, we had some of the outputs were the same for the function, and we want to distinguish those for where the outputs are all different. And for that, we're going to give a name to injective. So what we mean by injective is that there are no two inputs that have the same output. So that means all the outputs are different for different inputs. So let's look at an example, F, where the domain is just a set of letters A, B, C, D, and E, and the outputs are going to be real numbers. And then we're going to define F as follows. And the question is that going to be injective or not? If we look at the second and fourth columns, f of b is equal to 5. F of d is also equal to 5. That means we have two inputs that have the same output 5, which means that f is not injective. However, if I let f be this function, a, b, c, d, and e are the inputs, the outputs are 2, 5, 3, 7, and 0. Each output is paired with exactly one input. You don't have any repeats of outputs on that bottom row. That means the function is injective. So another question that we can ask if we want about a function is something that was probably bugging you about the distinction between codomain and range, right? So the question is, how much of the codomain consists of actual outputs? And what that's going to lead us to is the concept of surjective functions. So let f be a function from the set A to the set B. We say that f is surjective if every element of the codomain B is an output of f. In other words, the range and the codomain are the same. So remember, back in the old days, we were allowing the codomain to have more elements than there were outputs, right? But in the case where the codomain consists only of the outputs, that is the situation where f is surjective. All right, so let's look at an example. So here we have a function f from the set containing a, b, c, and d to the set containing 2, 5, and 8. And here's a function here, and our function here. And notice that our function is not injective. We're not looking at an injective in this example, but notice that f of b and f of d are both equal to 2. So it's not injective, but the question is it surjective? Now, surjective, we don't care how many times an output shows up as an output for different inputs. What we care about is all the outputs used or all the elements of the codomain used as outputs. So if we look at f of b, that gives us 2, f of c, that gives us 5, and f of a, that gives us 8. We haven't even looked at all the different inputs and outputs, but notice that even just looking at those three, we get all three elements of our codomain. So every element of our codomain is an output, right? 2 is an output from with B as the input, 5 is an output where C is the input, and 8 is an output where A is the input. 2 is also an output for D, but we don't care as long as all of them are represented as outputs. That means F is going to be surjective. However, if our F is instead with the same domain and codomain given by the following, A, B, C, D, with outputs 5, 2, 2, 5. So note that if you look at that bottom row, you don't see an 8 anywhere. So that means 8 is never an output of that function, which means not every element of the codomain is an output, and so F is not surjective. And so one important concept here is whether or not F is surjective depends on what the codomain is. For instance, if I looked at both of those functions and added in a 10 to the codomain, which would still be consistent with those being functions, neither one would be surjective because none of them would have 10 as an output. So it's very much, you need to know the codomain before you can say whether a function is surjective. All right, so let's give an example where those are examples where we had function basically as ordered pairs or tables or things like that. Let's look at a function as a formula and see how we can analyze that one. So this is just our old friend f of x equals x squared, and our domain is the real numbers, and our codomain is also the set of real numbers. All right, so let's see, first ask ourselves, is this a surjective function? Well, one of the things that you might recognize about x squared, and actually we have in previous videos, is that whatever x is, when you square it, you always get a non-negative number. You can never square a real number and get a negative real number, which means all the negative real numbers are not going to be outputs, even though they are part of the codomain. So that tells us that f is not surjective. That's all right. Now the question is it going to be injective? Well, there we might want to look at some examples just to get an idea of what's going on. So we might look at f of 3, and when we put that into the function, 3 is an input, we get 3 squared, which is 9, as an output. If we do the same thing to negative 3 as an input, we get negative 3 squared, and that also gives us 9. So what we have there is 2 inputs, 3 and negative 3. They both give us the same output, which means that f is not injective either. So it's not surjective, it's not injective. Now, what we haven't dealt with yet, and what I will lead you to that, and we'll go into more detail in the next video, is how would you show a function with a given formula is injective or is surjective, right? We've been doing a lot of, I mean, in this example up here, it was neither surjective nor injective, and we could do it by just having examples of things that didn't work. But how do you show it always does work if that is the case? Well, that's something that you're going to address in the in-class activities, and again, once you work through those and listen to the next video, hopefully that'll give you an idea about how to do those things in general. But surprises in your future. All right, so now it's time for you to work on Introduction to Injective and Surjective Functions. That's the first set of activities that go with this video. There is also one called Injective Functions, and you've got a rich supply of activities. You have a third one called Surjective Functions. All those are on the PDF files included with this video.